All right, this topic is on matrix multiplication. So we're going to start off with an example. A teacher assigns final grades based on a weighted system. Students are graded on unit assessments, a semester project, and the final exam, each with different weights. The matrix below is the representation of the weights for each kind of work, and the grades for each of the two students, Oscar and Reagan. So you'll see matrix on the left shows the weights, and the matrix on the right shows the grades for Oscar and Reagan. So what we're going to ask you to do is to figure out what are the final grades for each student. So what we're going to do is we're going to take the sum of those weighted grades. So we'll start off with writing down the final grade for a student is going to be taking 0.5, so the unit 0.5 times the unit grade. So think about 50% plus 0.3, 30%, times their project grade plus 20% of their final grade. And that's going to give you the student's final grade. So this equation shows that multiplying each of these is like multiplying the rows and the columns in a matrix. So what I've done for you is the completed work. So here's Oscar, and it shows the rows by the column. So what we do is when we do matrix multiplication, we take the first element to this first element. So we call row by column. And then we do the second element to the second element, and then the third element to the third element. So you're seeing these being produced right here. And you're going to get Oscar to get a score of 88.5. Now we'll do the same thing with Reagan. We take a 50% times 80, and then we take a 30% times 70, and then we take a 20% times 85. And then her score will be a 78. And that's a way that we can do a matrix multiplication to figure out a student's final grade. All right, here's example 2. Over 2 days, the school store sold the following amounts of pencils, erasers, and 3-ring binders. So on Monday, there were 48 pencils, 7 erasers, and 9 3-ring binders. On Tuesday, there were 54 pencils, 10 erasers, and 6 3-ring binders. And then we have some costs involved with each of those items. And we want to figure out how much money was made in each day, and we want to show the calculations. So what we're going to do is we're going to set up a matrix multiplication. So one way we could do that is just an old-fashioned way is we would multiply. Before matrix multiplication, we would take 48 times 0.2 plus 7 times 35 cents plus 9 times 285, and we would get the total. And then we would do the same thing for Tuesday. We would take 54 times 0.20 plus 10 times 0.35, and then 6 times 285 to get our totals. That would give us, in this case in the green, $37.70, And then in the red, $31.40. What we're going to do instead is set up matrices instead and multiply the rows and columns together instead. Okay. So we're going to go ahead and translate this into matrices. So we're going to let matrix A be a 3 by 2 matrix. And we're going to let that be the amount sold each day. So here's matrix A. So we have 48, 7, and 9. So that's the first day. That was Monday. And then the second day, on Tuesday, they sold 54, 10, and 6. This was on Tuesday. And then matrix B is going to represent the cost of each of those items. So 20 cents, 35 cents, and then $2.85. And what we're going to do is we're going to multiply A times B. So we're going to do the row times column. So I'm just going to do this for Monday. So you would take, for Monday, I'm going to change colors here. You would take 48 times 20. Then you would take 7 times 35. And then you would take 9 times 285. And that would give you the total for Monday's sales that are sold. Okay, multiplying by hand. When we multiply matrices, we want to make sure that our columns in A equal the columns in B, so that when we're done, the product of M and N will be the final product. So our N and N are going to be the same, so our final product will produce an M times P. So here's what I mean. Looking at these two matrices, we have a matrix A, which is a 2 by 3, and we have a matrix B, which is a 3 by 4. So in order for us to be able to multiply these two matrices together, they both must be this same number right here, and which they are. So then what it's going to produce is a 2 by 4 matrix. So that's what the outcome will be, is a 2 by 4 matrix. So now let's show you on the second example. So here's another matrix example in matrix C and D. So we have matrix C, which is a 3 by 2, and matrix D, which is a 3 by 5. Notice these two numbers right here. They're not the same number, so you can't multiply them together, because those two numbers are not the same. So not every set of matrices can you multiply together. Again, you have to have these inside numbers exactly the same, and if that's the case, then the outside numbers will produce the dimensions. All right, continuing on. Example 3 says, find the product of these two matrices. So first we have to do is we have to see, are these two matrices able to be multiplied together? So the first matrix is a 2 by 2 matrix. The second matrix is a 2 by 2 matrix. So then what we do is we look at the inside numbers. They are the same. We're good to go. So then the outside numbers will be what type of matrix we're going to have. So we're going to have a 2 by 2 matrix. So we're going to have a matrix that looks like this. C11, C12, C21, C22. Again, this is a 2 by 2 matrix. So what we're going to do is we're going to go ahead and multiply each of the rows by the columns to figure out what the value of each of these elements. So here is our first row, and this is our first column. So we want to find out what this element is right there. So I call that C11. So we're going to multiply 4 times 3, and then add -6 times -6. So again, I'm just going to erase this stuff here so you can see what I'm doing. So you're multiplying the first element to the first element, and then the second element to the second element. And then we simplify that number. We can just use our calculator, and we're going to get 48. So this will represent, I'm just going to erase this. So this will give us the value of C11, 48. Now let's go ahead and find C12. Let me erase all this here too so you can make this a little bit bigger. So now we want to find this number right here. So we're going to take row 1 again, and now we go to column 2. So we're going to take the first element to the first element. So 4 times 6 plus second element, second element. So we're going to get -6 times +1. And we enter that into our calculator and we'll get 18. So that element right there is 18. Now we're going to go down to C21. So column 2, or row 2, column 1. So we're going to take this row, second row, first column. So we're going to take 6 times 3 plus 2 times -6. Type it into our calculator, and we get 6. So that's that element there. Our last one, row 2, column 2. So we multiply row 2, column 2. First element, second element, second element. So we're going to multiply 6 times 6 plus 2 times 1. Enter it into our calculator, and that will be our final answer. This is our matrix, a 2 by 2 matrix. All right, let's continue on. Here's another matrices set to multiply together. So the first matrix is a 2 by 1 matrix. The second matrix is a 1 by 2. So we need to see, can we multiply these two together? Yes. The reason why is these two numbers are exactly the same. So then the exterior are what's going to produce the type of matrix we're going to have. So we're going to have a 2 by 2 matrix. So we're going to have the same as the last one. So we're going to have a C11, a C12. So again, a 2 by 2 matrix, 2 by 2. we want to find out what those 4 elements are. So we'll just start off with finding this element right here. So we multiply row 1, column 1. So 6 times -5, which is -30. Then we do C1, 2. So row 1, column 2, 6 times 4, and we get 24. So we've done row 1, now we go down to row 2. So row 2, column 1. So -3 times -5 is 15. And then our last one, row 2, column 1. -3 times +4 is -12. So there are our 4 elements, and now we just write the matrix. So -30, +24, +15, and -12. Here's one more. This is now a 3 by 2 matrix, and then a 2 by 2 matrix. So the inside numbers are the same. So the outside numbers will tell you what type of matrix you'll have, a 3 by 2. So you're going to have a 3 by 2 matrix. This will be a C11, C21, C31, C12, C22, C32. Okay. I'm not going to do all of these multiplication, but here's the process that you go through. You're going to multiply row 1 to column 1, and that'll give you that first element. So C11. So you multiply the first element to the first element, second element to the second element. So you're going to get 0 times -4 plus 5 times -2. And then you simplify that and you get -8. Now, I'm just going to stop there. Then you would go first row again to the second column, and that would produce this one. Okay. Continuing on, then you would go to the second row, first column. Then you would go to second row, second column, and get those next 2 elements. Then you would go to the third row, first column. Then you go to the third row, second column. Those are your last 2 elements. And that's the process we go through to multiply 2 matrices together. But again, please make sure that when you're multiplying 2 matrices together, A times B, that you have to check to make sure that the matrix are able to be multiplied together. So again, the rule is M times N, and then N times P. These 2 numbers must be the same, so then the dimensions will be these, an M times P matrix.